Hello and welcome to this podcast for Electropages. I'm your host, Robin Mitchell. In today's episode, we've got two very special guests from our favourite company, Flip Electronics, who have now merged with Resurgent, and we are joined by Duker Dapper and Bill Bradford. So Duker Dapper, could you take it away? Tell us who you are, what you're doing here, and how things are going to go down the line.
Certainly. So Duker Dapper, I'm the Vice President and General Manager of Resurgent Manufacturing Services. And Resurgent is a wholly owned subsidiary of Flip Electronics. Our goal is to extend the life cycle of semiconductor products through continued manufacturing. So generally, we obtain a manufacturing license right to continue to manufacture a product and supply it to our customer base that is currently using the product, allowing them not to need to redesign their product and ultimately extend the life cycles of their end products that are using those semiconductor components.
Very, very nice. And we also have a new guest, which is Bill Bradford, I believe the president of Flip Electronics.
That's correct. Yeah, thanks for having us on the podcast today. We're excited to be here.
No worries. So could you also introduce yourself, what you do, and what the things you like to do in your free time?
Absolutely. So I am the president of Flip Electronics. Flip is about a 9-year-old company that was formed as a specialty distributor to really focus on the issues of obsolescence in the semiconductor world. We'll get into that, I guess, a little bit more. I've spent my entire 35-plus year career in the semiconductor industry, most of that with manufacturers. So I've dealt with the issue of obsolescence from perspective of manufacturers that have to move on to the next node of technology and always trying to balance that with the needs of customers that have long-term support requirements. My free time, what little of it there is, recently has been dedicated to new grandchildren. So that's my
new grandchildren.
My second career as grandpa.
And you don't, I'll tell you now, you don't look it.
Well, thank you.
Well, thank goodness. Because my parents are now grandchildren, they're grandparents, sorry. And of course, at some point, they start to realize that they don't look old, but they feel old, and time catches up. So hopefully it doesn't happen to you during the period of this podcast. Anyway.
That's right.
Anyway, so let's get down to business. So we all know that Flip Electronics and your specialty is obsolescence, and it's basically trying to get customers who need parts for like a long lifespan and getting them into products, especially when they stop being made. My first question to both of you, and let's start with Duker Dapper, is what's the biggest challenge that engineers face when they want to incorporate obsolescent components into their projects?
So the biggest challenge they face is they have to make a decision, and it's an engineering and a business decision, really. They have to make a decision. Are they going to continue with the current component, or are they going to incur the cost and effort to redesign their product to use some other similar function semiconductor product that can substitute for the obsoleted product? So that's an engineering decision in terms of there's requalifications that sometimes have to happen. There's obviously design effort that's got to be done. And then there's also the effect on the user of that product. So, say it's a medical device, there's the impact on the hospitals or the doctors or whoever's using that product. They may have to requalify it, and they have to take certain measures, to continue to use that product. So there's a whole chain of knock-on effects that happen in the flow in the supply chain for an end user product that are impacted by a semiconductor obsolescence event. And so what we're trying to do, obviously what we're trying to do is lessen that event, keep those events from happening and allow those companies that are using the semiconductor products to continue to enjoy the secure supply chain with high quality product over a longer term. So that's what we're really all about. And in we can discuss more, but in the Ampleon case, with RF products, that is especially acute with the effort that it takes to redesign and potential qualification implications. So there's a huge knock-on effect and a potentially tremendous cost to the user of the semiconductor component as a result of an obsolescence event.
And what kind of what would you say is why is it that people need to rely on obsolescent parts? What is it about them that makes it difficult to basically get onto a new part?
Well, there's primarily is as I mentioned, it's the effort to redesign, but oftentimes it's more the effort to requalify the end product, the user product, in the application. We're discussing right now as an example, we're discussing a memory that's been EOL'd with a company that manufactures industrial equipment, and it turns out that it's the construction equipment industry. So all this construction equipment has to have EPA certification. If they change this one memory, that'll mandate a software change, which means in over 1,000 instances, they have to requalify that product with the EPA. Well, you can imagine what type of qualification burden that puts on the manufacturer of the construction equipment. So that's an example of where sometimes you don't realize, but these knock-on effects and these redesign and requalification efforts can run in the millions of dollars, tens of millions of dollars to execute them. Not only that, but not only the cost, but you also have a long time delay, and so it delays delivery of the product. So what's driving people to continue to use obsolete products is that the cost and the effort to redesign and or requalify is just too high. It's a huge effort, and if there's no performance benefit that you're going to get out of it, then if you can avoid it, then that's a huge benefit for the semiconductor user.
Yeah, and if I may just add to that, Robin,
absolutely,
there are two factors that are kind of fundamentally at odds with each other in this whole semiconductor space. Moore's law, which has driven the semiconductor industry for the last 50 years, is this constant push to get to the next technology node, the next level of performance. So the producers of semiconductors are constantly pushing that way, whereas a lot of industries just don't move that fast, right? Your toaster doesn't need the highest performing part in it, right? And that while toasters may be a silly example, as Duker mentioned, medical equipment, mil-aero equipment, things like that require a extensive amount of not just redesign costs, but additional testing, additional qualification, so a lot of additional time and money. So Flip has existed to try to fill the gap with whatever finite level of inventory is still available to support those needs. But we show that when a company, when a supplier end-of-lifes a part and does a last time buy, on average, customers only buy about 40% of the actual end-of-life quantity required. They just don't have the budget or the forecasting ability or the wherewithal to buy enough product. That always leaves this gap. Until we acquired a Resurgent, our only solution to fill that gap was with a finite amount of obsolete material that was left, that we had on our shelves. Now we're able to continue through a manufacturing flow to keep supporting those toasters or that medical equipment, those A&D requirements that need this constant source of supply, so they can, as Duker said, really avoid this significant cost, significant time commitment to redesign into a newer technology that they really just don't need.
I can think. Do you know what? I can actually think of one great example about the difference between new technologies and old technologies, and why those old technologies are probably more prevalent in certain safety critical industries. And one of them actually came to my mind was a certain, let's say a spaceship faring company who shall not be named on this podcast for whatever reason. But when I saw the internals of their ship in the crew area, it was kind of outfitted with modern flat screens and touch screens and all this kind of stuff. And while it looked really nice and fancy, if I had to choose, I'd rather go for the one that was based on valves and big switch buttons, because you know that thing's been proven and tested for 50 years and it hasn't failed in all that time. But if you bring these kind of technologies too quickly into those industries, you can't be sure that it's going to work every single time. So I can definitely understand why, like you say, the obsolescence, the need for those components comes down to the fact that they're tried, they're tested, and they're proven. But would you say that how big of a problem would you say is that recertification compared to simply not being able to get the parts themselves?
So it depends a lot on the industry, right? Again, if I cite the toaster example, it's not a big deal at all, right? And the consumer buys the next level of toaster. If it's medical equipment that requires a lot of government approvals, clinical trials, perhaps, all sorts of evidence to make sure that that new technology will actually perform as required with the quality that's required. So absolutely industry dependent, but certain industries, it's prohibitive. It can, redesigns themselves can run into millions of dollars, and the certification process can add millions on top of that, as well as years of time.
And so it's just a lot easier to just keep a hold of those obsolete components and use them in the products as they're being made. But like you say, the issue with that is you've got to find them in the first place, which then brings me to my another question, which is, from your experience, Bill, how much of a problem do you think counterfeit integrated circuits are in this field?
It's a huge issue for our industry. Some estimate that there's about $17 billion a year of counterfeit product. And counterfeit, it can be, the broad definition of counterfeit when it comes to semiconductors is not just out and out fake product, maybe packages with no die inside. It may be a redesigned die to try to meet the functionality. It could even be genuine parts, but that were mishandled and lost in the chain of custody, and so therefore are of suspect quality. But counterfeit is a significant issue, and obsolescence and counterfeit are very well tied. In fact, Flip performed a study a couple of years ago comparing parts that had been end of life and counterfeit reports into the database that companies report those incidents. And we definitely saw a correlation, and it only makes sense, right? That once a part's obsolete, it's harder and harder to find. Therefore, a market for a substitute, even a counterfeit substitute, is created. So it's a significant problem for the industry, for the safety of users of many types of end equipment. So that's absolutely a major function of why a authorized source of product, whether that's as a distributor or a manufacturer, is so critical.
So on the topic of supply chain management and sort of like supply chain integrity, what would you say, how do companies try to ensure that let's say a particular product that's been put in storage has got that kind of like, I'm not sure how you describe it, it's almost like a proof that it's been kept by a certain company in certain conditions and it hasn't been mishandled at some point in its storage?
So that comes down to, are you buying the product from, in Flip's case, we're an authorized distributor for many OCM manufacturers. So are you buying it from an authorized source? Meaning, do you have the manufacturer's authorization to sell that product? And you mentioned that sometimes, and so we source all of our products exclusively from manufacturers. So we're buying from the OCM. We're not buying from a Flextronics or somebody like that who has excess inventory, and therefore we're bringing that product in with potentially storage issues, mishandling, exactly as you've mentioned. So we have a well-defined process for making sure that we have good product coming in. But you're right, that is an issue, and it all depends on the source of, where are you getting the product from? Are you buying it from a broker in the in the gray market, or a broker, or are you buying it from an authorized source? And clearly buying from an authorized source where we have that relationship with the OCM manufacturers ensures the quality of the product.
And I think
the only 100% way to ensure against counterfeit, right? You can counterfeit. There are all types of counterfeit tests to mitigate those risks.
Yeah.
But at the end of the day, you'll reduce the level of uncertainty about a product. But the only way to know it's an authentic part is to buy it directly from the source or through their authorized channel. And
so in the case of Flip Electronics, what you're essentially saying is that the supply chain, the number of hands that part sort of like exchanges is just one. It goes from the original manufacturer who's about to make a part obsolete. You buy those in bulk, goes into your warehouse, and then the moment the customer wants to use it 20 years down the line, straight to them. But the chain is only sort of like 3 people long, them, you, and the customer. And so, whereas, I mean, because I can imagine there are plenty of distributors out there, really big names, and obviously they're also authorized sellers, but they'll be buying parts from the original manufacturer, but then they're going to try and get rid of those parts. So someone else then might buy those parts to store, and then you have more and more people in that chain, and there are more parts in that chain that can go wrong. So like you say, it's critical that if you're designing something with obsolescence in mind, you need to make sure that the parts that you're purchasing from have gone from the original manufacturer to one authorized reseller and then straight into their product in the future, which I think, which actually brings me to another question, because if I remember correctly from our last podcast, Resurgent deals with the wafer level of storage. Am I correct in thinking that? And Flip Electronics is the whole package, including the outline and the pins?
Well, Resurgent, we deal with, so yes, we do store wafers to directly answer your questions, but we also purchase wafers from foundries. So the best way to think about Resurgent is we're a fabless semiconductor company,
right?
A fabless semiconductor manufacturing organization, because we're not an independent company. We're a fabless semiconductor organization, but we don't design our own products. Our products come to us via licensing agreements with OCMs. So that's the difference. So we are capable, and we do right now, order from foundries. We order wafers, and this is part of continuing the supply for a longer term, and also having fresh product available is executing the entire manufacturing flow from wafer foundry to finished goods. Now, in some cases, depending on, and sometimes obsolescence events are created by a foundry EOLing a process. And in that case, we'll do a last time wafer buy, and we will store the wafers and use them as demand dictates. But so there's different operating models in terms of where we acquire the inventory and how that inventory is then moved into finished goods. That's
actually really, really interesting, because it's not just that the part themselves can become, the part itself can become obsolete, but also the process which you use to make it. And so even if you have the IP to design that chip, even if you have the capability to manufacture a functional equivalent, because you can't use the same process, it may not be able to, or it won't carry the same, as you said before, it won't be able to pass all the qualifications that the original part would have done, because you'd have to get it reassessed, I imagine. Is that correct?
Yes. So if take the example of, the most extreme example would be if a foundry EOLs a process, and you need to take that design and transfer it to another foundry, should you decide to do that. Well, that again, that's a large burden on the semiconductor manufacturer, the fabless company, because that is a long qualification cycle there, and you've got to recharacterize. It's almost like building the part, designing and building the part all over. But if you can continue the manufacturing and/or you buy the die, you can hold on to it, store that die and move it into finished goods as need be. The other thing that happens is, again, the end customer is affected with that, because if you change foundries or if you change assembly locations, and in some cases even test locations, meaning the physical location where you do the testing, the electrical testing of the product, oftentimes that will trigger a requalification at the end user, at the semiconductor customer. So there's an effect on the customer as well as needing to transfer the product, and that's something that we do. If say that in the instance where a package is EOL'd by one manufacturer, by one OSAT assembly outside a semiconductor assembly and test house, if they EOL the package because their demand has gone down, whatever business reasons they have for doing that, we can oftentimes the OC, if it's an older product that is lower volume, it doesn't make sense economically for the OCM to requalify that package at another supplier and continue producing it. So they'll just EOL it. And what we can do is we can come in and take that product and requalify it at a new manufacturer, because that's what we do, and continue to build the product. And or in one case, we actually, it was a BGA product where the substrate supplier had EOL'd the substrate. And this was exactly the case. It was an older product, lower volume, and the OCM made the decision, well, we're not going to redesign and requalify the substrate. So we redesigned the substrate, we requalified the substrate, and we're now continuing to produce the part. And then we just actually got qualification on that last week. So the part is now fully qualified. It's used in the A&D space, and so this was a big deal for the aerospace and for some defense manufacturers, because they were going to have to requalify their entire, in some cases it's going into avionics. And so they're going to have to requalify an entire airplane because of because one substrate was EOL'd. So that's the type of problem that we can take care of.
That is absolutely crazy to think that one small part having a slightly different substrate can result in the requalification of the entire product that it's built around. And so that's really interesting, because then it's not just the fact that a part's gone obsolete and its process is end of life, but then the testing procedures are also, if they're moved, like you say, to a different facility, because you can't be sure of the testing standards that facility is going to have compared to the first one, making sure that it follows the exact sort of same steps. It just changes the entire nature of that part, and so it becomes hard to trust and rely on it. So would it be fair to say that if you had a part that was you had the actual IP and you had the process, but if you couldn't do the testing, it would count as a counterfeit if it wasn't properly tested?
Yeah, because what you risk is that you're going to defect is going to get out of the test factory, and that's going to end up in the customer's board. And one problem is with parts that are more and more complex, especially things like microprocessors and those types of parts. Even though you're doing an extensive electrical test, sometimes there's defects that you can't detect at electrical test, and they only show up in the customer's system or the customer's product, and that's really devastating, because now they've got the part on the board, they've got the product built, and they find an error, they find a problem, and so that's extremely expensive for the end customer. And another case where you want to have authorized product, because you be sure that product is meeting the specifications.
And I think what I would like to say as well is that before this podcast, if someone asked me what was a counterfeit part, I would say a part that's not made by the original manufacturer, or maybe it's a defect from a wafer, or a rejected part that was out of spec. But it never occurred to me that even an old part from an original manufacturer could still be considered counterfeit if it wasn't stored properly or tested properly. It never occurred to me that itself could qualify that as being a counterfeit. So I think, knowing that, I can actually see the industry facing counterfeits as a serious issue, because I've seen old parts circulate all the time. And I can imagine if you're building something, let's say, I don't know, a missile system or whatever I don't know what it is you're going to build, that's reliant on components from the past. Because I know for a fact that there are some systems that are still reliant on the Z80 processors from like 1984. So I can imagine that as an engineer, it might be very easy to go, oh, this seller's got 100, I'll buy those, stick them in, they're the same part technically. But you don't know where those parts have been, you don't know if they're made by the same manufacturer, you don't even know if they've been tested to the same standards. And even if they have been, if they've not been stored correctly, they still might have issues that will come up later in the design. So on the topic of the whole process of manufacturing old processes, old fabrication techniques, I'd like to ask you a little bit about this. Is it Ampleon, this new partnership you are currently working with?
I'll start and let you dive into the details. So Ampleon was a spin out of NXP. Does a lot of RF products serving the communication space, telecom space. So very complex products. RF is probably arguably one of the more complex products to certify, to qualify, because of the complexities around testing an RF product. But they have chosen to end of life a family of products in the RF arena, the family called ICN8. And these transceivers, RF transceivers, are critical for a lot of telecom companies that have systems that they're intended to serve the marketplace for another couple decades. So we partnered with Ampleon to, as Duker mentioned, our Resurgent business model, to license the manufacturing flow, to continue to support. In this case, the foundry source is going away. So in this case, this is a situation where we are in the process of having a last time buy of a significant amount of die wafer that we will store to be able to support more than a 20-year life cycle for the customer base. Duker, you can certainly provide a little more detail on how Resurgent's working with Ampleon in this case.
Sure. So we are, as you mentioned, Robin, we're using the same IP. And in this case, actually, Ampleon is going to act as the assembly and test
Right.
subcontractor. So they're going to continue to build the parts in their factory. We decided, as Bill mentioned, because of the complexities of RF and because of the requalification and the strict rules and regulations around that, we are actually going to continue to use the Ampleon mark, the Ampleon part number. So the parts will look, and again, our goal is always to make parts form fit compatible and virtually drop-in replacement identical to the OCM by using the same manufacturing process and locations as the OCM. In this case, we're doing exactly that. So the product will be identical from what Ampleon is producing today. It will look the same. Virtually the only difference is that the packing labels on the boxes and the shipping materials will say Resurgent instead of Ampleon. But other than that, there'll be no change.
So in the case with Ampleon and this and the RF parts that have now gone end of life, is it also the process that's gone end of life as well?
So yes, that's correct. In this particular case, the foundry that Ampleon is working with is EOLing the process. And again, rather than trying to transfer these parts, especially RF parts, which are very sensitive to changes in process conditions, Ampleon chose that they decided they're going to EOL the parts, but they didn't want to EOL because of the impact of the customer. So they sought out a third party. They had a competitive bidding process, and Flip won the bid. And so we will be their partner moving forward to continue to build the parts. And we will do a last time buy from exactly the same foundry that Ampleon is using. And in this particular case, Ampleon is actually going to act as the OSAT, so they'll be doing the back end assembly and test for us as well. So the parts will be exactly identical to what Ampleon currently supplies.
So this was going to relate to a question I wanted to ask you. So what's happening is that Ampleon have end of life this part because the process as well is also end of life, and so you are essentially coming in, purchasing the wafers and storing them. And then that allows them to then take those wafers later and then repackage them, test them, so they can continue to manufacture their own silicon chip, even though that process that they rely on is then no more.
Correct. So
I'd like to quickly mention them because that's really interesting, because I've always looked at Flip Electronics and Resurgent as being kind of you store chips for engineers who may be building products and need the end of life kind of help. But it never occurred to me that you could also help semiconductor companies who themselves want to keep selling their semiconductor products, but they can't because their manufacturer has basically stopped that process.
Yeah, let me be clear about one point. We are now the seller of record of these products. So Ampleon is out of it in terms of selling the product and or providing support and service. But you're exactly right. We try to create what we call a win-win-win situation. And by that, we mean a win for the OCM. And in this case, as you mentioned, we're helping Ampleon because they had a decision to make that was going to cause issues with their customers. We try to create a win for the customers. They get to continue to use the same part without requalification. And we're trying to create a win for ourselves. We're, of course, in business, too. So we need to be able to make a profit as well.
And I think it's also interesting to see that that wafer storage allows you to, the storage density of wafers is, I would imagine, several orders of magnitude greater than tubes of IC parts and reels. So I take it that the merging between Flip Electronics and Resurgent has managed to help both sides increase their ability to provide obsolete parts.
Well, it's not only the storage space, but it's also the cost. So when you're buying finished goods, you're paying the total cost of the product. If you're buying die and wafers up front, you're only paying a percentage of the final cost. So less money invested up front, and it's a matter of return on capital as well. The financial model is more advantageous if you can buy wafers versus finished goods as well.
And if I remember correctly from our last conversation, I think we were saying that in terms of the wafers, their life or their shelf life was virtually infinite compared to packages which can get damaged by humidity, temperature variations, and other environmental factors.
Yes, wafers can live. Wafers can be stored virtually indefinitely. And I will say that packages can generally be stored indefinitely too under the right conditions. Now, there may be some degradation in the leads, but you can generally clean those up. But certainly wafers, the storage conditions are such that they can be stored indefinitely, and they do take less space. So you're talking about less space for storage on the wafer side, and as well as less capital invested up front.
And in terms of storage condition, I suspect that with wafers, I think they're in sealed boxes with like a nitrogen inner atmosphere. But if you've got reels of obsolete parts, it's probably harder to do that.
Yeah, although it's sealed, vacuum sealed moisture barrier boxes that this product is stored in are very robust. So I'm not going to throw a dagger at that.
Of course.
But the wafers are similarly as wafer storage is similarly as robust, and again they're kept in a nitrogen purge environment, so their lifetime is very long.
So in terms of examples, do you have any examples you could share of customers who have relied on these type of RF parts from Ampleon and have managed to essentially continue their projects without needing to redesign and requalify?
Yeah, I mean, virtually the entire customer set for this product family. We have, since the announcement earlier this year, we've engaged with all those customers to provide them the assurance of long-term commitment of supply. We have even some of the parts from that family that were EOL'd previously, we have announced that they can continue to buy that product as well from Flip. So it's kind of business as usual in this case. I think we could probably relate a couple other transceiver case from another supplier where they were running completely out of options, and Duker was able to come up. Do you want to talk a little about the other example? I guess you mentioned it earlier, but maybe a little more detail, Duker.
In the case of the BGA redesign, this was a product for, the primary driver of it, how we got involved was through a military customer. And as I mentioned, literally this product goes into a modern fighter aircraft. And so if it's part of the electronic warfare avoidance. So if they were going to have to change that module out, they were literally going to have to re-qualify that entire system. And so not only the component or the boards that this component went on would have to be requalified, but that entire warfare avoidance system would have to be requalified. So it was a major deal. And they were and in this particular case, the supply virtually stopped within 30 days because of the nature of the EOL. So they were in a very difficult position, and we came in and told them, yes, we can redesign the part, or redesign the substrate rather. We didn't redesign the silicon. Silicon is the OCM silicon. So the original manufacturers, silicon. We're also using their test program, so the test software, and we did transfer the test site, but the tester is the same tester, and the software is exactly the same. So we're using the same test conditions as the original component manufacturer. And the defense contractor right now is qualifying that part in their board. As I mentioned, we just finished our qualification. And so it pulled them out of a very desperate situation where they were, potentially, and again, this is a military aircraft that is sold not only in the United States, but it's sold worldwide. So you start to think about that, and you think, well, we're just we're just a company redesigning substrates, but the impact.
It's much more serious than that. It's potentially the difference between a country remaining sovereign and not if their aircraft stop working. Aircraft is a funny one because we've had guests on here before when we talked about counterfeits, and I heard of a horrific story of a fighter pilot being killed by his ejector seat not working correctly because they found there was a counterfeit part inside the aircraft that didn't allow the system to work correctly. Now, whether that was because of a bad supply chain or someone's made some bad decision in terms of where they source their parts from, they're not quite sure at this point. But, you know, people look at counterfeit parts, and I can imagine a lot of engineers go, it can't be that bad, surely. Well, yeah, and people have died as a result of not having those authentic parts. And then, as you imply with the fact that you have aircraft and equipment going all around the world, not having the correct parts could be the difference between a country remaining free and not. So, so you say you may be only one small company, but it's crucial. It's like the keystone of a bridge. You take that away, and the entire thing crumbles. But one thing I'd also like to ask is, going forward with the parts that you can procure and obtain, what do you see Flip Electronics and Resurgence doing over the next sort of 10 years?
Yeah, so as I mentioned at the onset of this podcast, this acquisition of Resurgent has really boosted our ability to be a broad solution provider for obsolescence needs in the industry. We're working closer and closer, not just with our customers, but also with suppliers as they're starting to contemplate their product life cycles and starting to be a little more strategic about planning an end-of-life event, the last time buy strategies that can help them monetize most effectively and provide the most customer satisfaction. It takes a little bit of planning, and so we try to partner with our key OCMs right up front. As they're first contemplating the obsolescence of a product or a product family, and we are really becoming consultative partners in that whole process. It's an issue that's not going away, but with a little bit of foresight, instead of an afterthought where all of a sudden you're abruptly end of life in a product and customers are caught in the lurch. With a little bit of planning, whether that's buying a sufficient number of finished goods or licensing through Resurgent the ability to continue to manufacture this product over a long period of time, we just are really trying to, both to our customers and to our suppliers, advise them in this critical area.
And that sounds like like you say about instead of reacting to the industry, you want to be at the forefront of it. So essentially, anticipating what might happen with customers. So it sounds like to me that you want to be kind of like with the customer during their initial design phase. So they say, "Oh, I'm going to choose these parts," and you could come in and say, "Well, that part's good, but this part might only have 5 years down the line before it goes away. So you need to consider that." And then the customer goes, "Oh, okay, thanks for letting me know. Now, if that part goes EOL, I know who to call." And like you said, and I've heard this before, that manufacturers of silicon chips and the wafers, they can just be like, one day we're going to stop making it, and suddenly you've got 30 days, and they don't even legally have to give you notice. They can just drop that whenever they feel like it. And so I think what you're saying is that the years of experience that you guys have built up, your ability to consult customers, allows you to stop being less of a manufacturer and supplier, and almost more, like you say, more consultation and planning. So people can produce projects with decades in mind. And I think a lot of engineers would love to have that kind of knowledge when they start designing a product. And I mean, the number of times I've designed a few products myself, and the number of times I've sat down with an engineer and they said, "Oh, let's use this part," and the first thing I say is, should we check the website and see when it was first manufactured, and is it going to be around in the next 10 years? Because you just don't know. And it's a real problem. So I think that's a fantastic direction for Flip and Resurgence to go, especially if you can get almost like you've got to get into the designing room when a product is first being conceived.
It's not a rare occasion that a complex system, by the time it gets fully certified down to production, already has obsolete components on board, and so
absolutely,
it's a huge issue.
And where would you see the future going, Duker?
I agree with Bill. We want to get more and more involved with not only the OCMs with which we partner, but the end customers as well, because the sooner we can engage on both sides, both the customer and with the OCM, to help them plan their strategy for an obsolescence event, the better off all three parties are going to be. And so getting into that consultative role and offering creative solutions, that's where I see this going. And ultimately we want Flip and Resurgent to be a first choice of OCMs when they consider this type of thing. So that's where we want to go, really, is when an OCM thinks of obsolescence, they think Flip Electronics. Let's talk to them and see what they can do to help us with this situation. Or when a customer sees an obsolescence event coming, because we don't have perfect clarity into the market. So, any additional intelligence we can get, when a customer sees a part being EOL'd or obsoleted, then they think, let's talk to Flip and see what they know about this.
That's absolutely
the tagline
fantastic.
we use often is making obsolescence obsolete, and that's absolutely what we're trying to do.
And I think that slogan perfectly fits this whole conversation. And I don't think better words have been said. So just before we wrap up, I've got a list of interesting things here, and one of them which comes to my attention, which I don't think we've discussed yet, is Hotlink. Does that ring a bell to anybody on this podcast?
Hotlink does ring a bell to me, yes. So the Hotlink, the product I described in terms of the BGA redesign, that was a Hotlink product, and that's
right. And so that whole example was Hotlink. Fair enough. I never heard the word Hotlink. I'm sitting thinking, oh, is there another example coming up? Oh, that's the Hotlink. Fantastic.
So Hotlink is a PHY transceiver that was built by Cypress Semiconductor, which is now Infineon. When was it originally designed? Probably early 2000s.
Is that the company with the tree logo?
Yes.
Yes, I remember those. That was a long time ago, though. Yes.
Product actually came out in the mid '90s. I remember it well as a sales guy for Cypress.
So Bill and I both have a Cypress background, Cypress Semiconductor, having worked there. But so the Hotlink product, there's two generations of it. There's a Hotlink 2, which are the SMPTE and video PHYs. And then there's also a Hotlink 1, which is also video PHYs, but different standards. So
right.
These older standards are still in use in a lot of industrial and as we described, military applications as well. And replacing them is a complete redesign and qualification. So we are producing the Hotlink 2 products right now, and we're trying to expand that portfolio with other products of a similar nature from Cypress and other OCMs as well. So we want to be able to provide this type of product on an ongoing basis to this customer base. We think there's a need in the marketplace, and there's availability. We can still build the product, so it's all there.
Fantastic. So before we wrap up this podcast, I've only got one more question for both of you, and I'll start with Bill. My question to you is, if there are customers out there who want to look more into Flip Electronics and Resurgence and the services that you offer, what would you recommend to do?
Yeah, easiest to quickly get information is to reach out to our website, flipelectronics.com. Certainly, I'm on LinkedIn, Duker's on LinkedIn. Reach out to us through that, and we can introduce you to the appropriate representation within Flip. But we'd love to have conversations about whether you're a customer or a supplier, how to help you better plan for and solve your obsolescence issues.
Fantastic. And what would you say to our audience, Duker?
I would say, echo what Bill said. If you are either an OCM thinking of an EOL event, or you're a user of semiconductor products impacted by an EOL event and still are having issues with supplying that part, reach out to us. I will say we can solve a lot of problems. We can't solve every problem, but where we can, we will dig in and help. If it means re-engineering the package, if it means recreating a test program, whatever needs to be done, we'll put resources on it and find a solution.
And as always, it's been great to have Flip Electronics on this podcast. So all I can say to the pair of you is thank you very much for your time.